Section 8.3, the inverse of a square matrix. So matrices can be added, subtracted, even multiplied together in some cases. Another idea that carries over from algebra we already know is the idea of inverses. So an inverse is a multiplicative inverse, something times something else equaling 1, the identity. So you have A and you have A inverse, and they can multiply together to give you the identity matrix. And the second identity matrix, 1's diagonally, 0's everywhere else. The third identity matrix, again looking for square matrices, 1's diagonally going from top left to bottom right, 0's everywhere else. So to show that B and A are inverse of each other, check them, multiply them together. Do AB, also do BA. So those two different multiplications. Check those, pause the video, check your work with my completed notes, then start the video back up. Another way to find an inverse if you're not given one, so you're not verifying two inverses, but you're gonna find an inverse. You can create an adjoining matrix. You're gonna adjoin an identity, and then you're gonna do row operations to turn the left side into an identity, and whatever happens to the right side happens. So we're going to focus on only the left side. We're going to do row operations to turn that into an identity matrix, and whatever happens on the right side happens. Just goes along for the ride. So first, let's get rid of that -1 in the bottom left corner. Going to add a row 1. So because we're adding into the second row, row 1 is not going to change. So 1 and -1 is 0, 4 and -3, 1. That's nice. 1 is 0 is 1, 0 and 1 is 1. Okay. And then from the second to the first, we're going to add a -4, row 2. So the second row is not changing. 0 and 1 is 1, -4 and 4 cancels off. So now we have the identity matrix on the left side. That's what we wanted. -4 and 1, -3, -4 and 0, -4. So we have our inverse. We'll call it A inverse. That's going to be the right half of that adjoining matrix, -3, -4, 1, and 1. Now that works for any size square matrix. For 2x2s specifically, there is a formula, a pretty easy formula you can use. And it uses what's called a determinant. So A is said to be invertible if and only if AD minus BC is not equal 0. See, here we have A, B, C, and D. AD, BC is the determinant of that matrix. So the formula is 1 over AD minus BC, so now you know why AD minus BC cannot equal 0. It can't have 0 in the denominator. Excuse me. If you're wearing headphones, I apologize. So then that determinant is going to get scalar multiplied into the emitters. But you need to reorder the entries also. So A and D are going to switch with each other, so now D and A. B and C are going to stay where they are, but they're going to be negative now. So negative B and negative C. And that's a pretty simple, much simpler way to deal with 2x2 inverses. So do those examples, check your answers with my complete notes online.